Hello and welcome to another not so entertaining but very educational video by Mr. Ewert. We're doing a grade 7 lesson on 8.1 parallel lines, and to do this today you're going to need paper, pencil, a ruler, a compass, and a protractor. If you're not sure where to get those, you can just go to the ugly colored bins on the side of the room. There's one with rulers and one with a whole bunch of geometry stuff. So now that you've got everything in place, we're going to talk about parallel lines. And if you look here on the screen, I'm going to move your cursor over. Oh, no, I don't think you can see that cursor. Well, we'll have to take a look in the textbook. If you look on the first page of the textbook, it compares parallel lines to that of a guitar or train tracks, etc. Parallel lines are those that never meet. So for example, if you were to have train tracks and the train tracks were not perfectly parallel, you would have a disaster on your hands. So if I've got train tracks here, parallel lines, if you were to extend them, would never meet. Like if I put laser beams that were powerful and could fire through space, they would never meet at any point. However, if I have two lines like this, you can clearly see that if this was a train track, the train would wreck itself. At some point, they're going to crisscross, and vice versa like this. So those are not parallel. So first we're going to teach you how to perfectly do parallel lines. In your textbook, it gives these directions, so although they will not be clear here, I will be going over them with the video and you should be able to follow along. So first take your blank paper and you're going to put it landscape or sideways as opposed to portrait landscape. I'm going to use a ruler and a pencil. You take your ruler and just a little off center, we are going to draw one line. So now you have a perfectly straight line across. Now most students at this point would go, well, duh, if I want to do a parallel line, I'll just measure and I'll just do it on the other side. But I'm going to show you a very technical way to do it. This is how you are instructed to do it within the textbook itself. On your line, just a little off to one side, give yourself a little dot. Once you have your little dot, you're going to take your protractor, and you have a T intersection on your protractor. You want to line that up with the line over the line and the T intersection on the dot. At 90 degrees, put a little tick mark like that. There's my 90-degree mark. Now you will make a second mark upon your paper. Where that second mark is, you will once again put the T intersection, make sure it is flat, and put a little mark at 90 degrees. You now have two secting points that you can put a line between. I'll take my ruler right to the end, and there we go. Now these two lines are perfectly parallel. If they went on forever, the presumption is that they would never meet. Of course, I can't be that quite machine precise, but we're pretty darn close. We have now followed the directions from the first page on how to draw a parallel line. Here is a second way that we can also come up with parallel lines, but this time we will use a compass. Now a compass is this happy little fellow right here. So you can flip your paper over or grab a new sheet if you need. Once again, we're going to start with a simple line. So I'm going to use my ruler. I'll make a line. And we're going to label the line A, B. So I have point A and point B. The next instruction says make any point D on AB, and it shows an example here. So I'm going to come up with a point here, which I will label D. The next instruction says place the compass point on D. Set the compass so the pencil point is on C. So that's where we're going to mark C like we did before. So let's mark C. Okay. We now have a point C. We'll take our compass. It says put the point on D, place it on C. You may need to adjust the size of your compass to get there. To do that, you can simply open or close. Some of them have a mechanism where you can tighten or loosen it there. Now, one problem I have with a compass is usually when you're going around, you end up squeezing at some point. So I like to go like this. I clear my desk of everything, and I just spin my paper like so, holding my compass steady. That usually makes a pretty good circle. There we have our circle. Very nice. We now have matched this. It says label point E where the circle intersects AB. So where the circle intersects line AB, we are to put point E. If at any point you're having a hard time following along, just pause the video. Whoop. Then it says, do not change the distance between the compass and pencil points. Place the compass point on E and draw a circle through D. So place the compass point on E, draw a circle through D. Once again, I'm just going to spin my paper so that I don't have to put any stress on the compass. And that gives me a very nice circle. I'll even darken the other circle from before just because I couldn't see it very well. There we go. So now we've accomplished the second part of how to do parallel lines. Now if I were to look at the top and the bottom, if I were to do a line that touches both of those circles, I have a line that is parallel to the first one. And if I do one that touches both of the tops, once again I will have a line that is parallel to AB. Now we are going to use a few different tools. We use a right triangle, we use a compass, a protractor, a ruler, and a pencil. And we're going to explore 4 of the 5 different ways to create a perpendicular line, which are outlined in 8.2 in the grade 7 textbook. One of them we're unable to do because it wants us to use a tool called a mirror, which we do not have in our possession. So way number 1, I'm going to start with a line segment, like this. We want perpendicular. Now perpendicular means a 90-degree angle. So we'll start with that. Let's take our protractor. We're going to mark a point on our line. If I put the line to line, T intersection to the point, I can give myself a 90-degree mark right there. And if I were to take point A and B here and mark them, I now have a line that is perpendicular to the other line. Now, of course, the easier way here is method 2. Just take a right triangle, line it up on the base, and then you can simply go like this, and once again, you have a 90-degree angle. Let's get to the more complicated versions of this. One method in your textbook asks for a mirror. Unfortunately, we don't have that, but we do have a compass. So let's take a look at how we could use a compass to get perfectly perpendicular lines. So first we'll start with a line. There is our line. Now we're going to mark that A and B. A, B. Take a random point and you will mark C. Now we take our compass, point on B, and we're going to draw a circle. I'll spin my page. There we go. Take a random point outside, label that C. Without changing the size of your compass, we want it the same distance as it was here. Put on C, draw another circle. Uh-oh, I just changed my distance by accident. I'll have to reset that. There we go. There we are. Where circle C intersects circle B, I'm going to make 2 points. Point 1, point 2. We will label those D and E. If I connect points D and E, once again, I have made a perfectly perpendicular line. So the methods that we just came up with, the first method we did was we used the protractor, line to line, intersection, 90 degrees, and draw the line. The second way that we did was we just used a right triangle to do. The third way that we did was we drew one circle with B, chose a random point, same size, did another circle with C, labeled the intersecting points D and E, and then drew the line for another perfectly perpendicular line. If you want to follow any of these steps, they are in 8.1, I believe, and 8.2 in the grade 7 textbook. That's for parallel and perpendicular lines, and hopefully this can help you out with your assignment. Feel free to ask Mr. Ewert for some help. I like helping.